This computer. Okay, so we're recording. So having done that, now I'm going to share. Okay, I'll share Canvas. So both of you are able to get into Canvas, right? No problems with Canvas? Okay.
No problem.
No problems at all.
Good, good, good.
Besides we have a quiz due today.
Yes, yes, we
and
do. Yeah.
I wanted to I'm scared to click on it because I mean, how are we, is it just like,
You're going to, well, you're going to, my quiz is just a file. It's a Word document. And yeah, that brings up a good point with my quizzes. Can you print? Can both of you print?
I can, yes.
Oh, good. And Tessa's nodding her head.
I can as well. Yeah.
Okay, perfect. Well, I've loaded in fact, if you want to do that right now, that's fine. I've loaded the quiz onto Canvas. So why don't you get in there and see if you can find it, print it out. It's 3 pages. Just print it out and set it aside, okay?
Now or what?
Yeah, you can go do it now. Yeah. Yeah, go ahead and do it now. We're going to do it at 6:15. But I'll let you just print it out now so you have it. That's all, you know.
Oh, okay.
Okay,
I
got
didn't
me?
mean to skip ahead. I just was kind of getting a little nervous about it since it was.
Well, don't. Yeah, I don't want you to get nervous about it. I just, you know, we'll go over it. Don't worry. I don't want. Yeah, don't get nervous about it. But, and just remember, there's 6 quizzes. 1 we throw out. Okay, the lowest one we throw out, and the other 5 count for 10% of the total grade. So they end up being like 2% each. So anyway, so can you both find the quiz? It's under quizzes and tests. Okay. Okay, Tess has already got it. So Miranda, are you able to find it and print it?
Yeah, I believe so. I went on there a couple times earlier today.
Well, but I just loaded it not too long ago.
Wait, what do you mean? What about?
Well, there's a document under tests and quizzes called quiz number 1. I want you to open that up and print it. Okay, because that's what you're going to do your tests on. Excuse me. And then you're just going to take a picture of it just like you do your homework and send it to me. And I'm going to grade it and I'll give you a grade and then we'll go over it next time. Okay. So you need to download that document and print it, just like Tessa just did. Okay. So Miranda, are you having any luck? Hey, Miranda?
Yeah, I'm printing it right now. Sorry.
Awesome.
You're
No,
right
that's
about the
okay.
video thing.
That's
it's
okay.
kinda,
That's okay. Awesome.
I'm having to pop.
I'm glad you're able
I'm
to
still
print it.
learning the navigation. So.
Okay. Well, yeah, just sort of play around with it, and you know. But yeah, so we're going to print the quizzes and tests out, and then you'll answer them, you know, and fill in the blanks essentially, and then take a copy of it and send it to me at the end of the class or whatever. Okay. So
Yeah, so
now
it's printing now. So
okay.
we're ready to go. If you're ready to move on, I am.
Yep.
Good.
Awesome. Okay. So the first thing is to review homework in 2.4. Did either of you have any questions? Anything you want me to go over on that? Any particular problems, or were they all pretty straightforward?
I don't think I had any. I think they were pretty
They are pretty
straightforward.
straightforward. I know
I have 2. I do have 2. I have 2 of them that I
Okay, well, let's talk. Just give me the number
Okay.
and where are the lighters? My fucking lighters. Yeah, Miranda, if you give me what number you're talking about, I'll bring it up on my screen and we'll go over it, okay? So I'm going to stop sharing that and go to my whiteboard. Okay, Tess, can you see my whiteboard? Okay, thank you. Okay, Miranda, what problem number? Miranda, are you there? Miranda, are you there? Yeah, this is when I can't see her and she's muted. I have no idea what's going on. Makes it really frustrating. Hey, Miranda. I mean, I know she's there. Well, maybe I should just go into the lecture. I don't. Miranda, I'm going to let you find it, but I don't know. I need to know whether you're there or not. Okay. So what's the problem number?
Sorry. I'm so sorry. Okay. 247.
Okay, 247. Okay.
I'm sorry.
Oh, that's okay.
Jeez.
So let's work on that one first. Let me
Okay.
247. Okay, so it looks like this. It's 8 times. Oops, sorry. I gotta put this over here so I can see it. 247, 8 times 6t, 6t minus 5. That's minus 35 is equal to minus 27. And I'll spread it out. So that's what the problem looks like, right? Boom. So what you want to do is you want to distribute that 8 across the 6t and the minus 5 to start out with. Ella, I see you're there. Good to have you. We're working on problem 247. So 8 times 6 is 48. So it's 48t. Then it's going to be minus 40. Minus 35 is equal to minus 27. So the first thing we want to do is collect the like terms on both sides. And so the way I do it, like this, and just a minute. So what I mean by that is I'm gonna add that to that. Okay. Like it thick. And so now when I do that, I get 48t and minus 75. Oops. Is equal to minus 27. Okay. But now I want to solve for t, so I have to move the 75 to the other side. I do that by adding 75 to both sides. So put 75 there, and I put a 75 there. And we're going to essentially add them. And so it looks like this if you remember how to do the 1 and 2 step problems. Just a minute. Change my deal. Deal like this. So you're adding up on the left side, and so it's going to be 48t because 75 and minus 75 is 0. So it's 48t, right? And on the right side, you've got minus 27 and 75. And that's minus it's 47, 48, right? 48, yeah, 48. So that's equal to 48. So see how easy. So now all we do is divide both sides by 48. And when you do that, you get t is equal to 1.
Yeah, I
Okay.
see what you gotta watch out is that simple math. If you make
Yeah.
one mistake, it throws the whole thing off.
Yeah,
So I got
sure
some
it
weird
does.
fraction because I didn't do my simple math right.
Yeah, you got, that's why I'm laying it out as simple as I can, so you don't
Well,
make
it's
any
not right,
mistakes.
but
Yeah.
when I'm at home, if I get that wrong, then it comes out wrong, you know?
No, I
I
understand, I
have to like
understand.
double check.
Right. I mean, if you use a calculator to figure, I mean, if you have to add
Yeah,
things
I just got a
together.
graphing one today, so that'll be helpful.
Okay, okay. So anyway, so that's how you do that, right? So what was the other one you had? Miranda, you there? Miranda, you said you had two. Do we want to work on another one or just go to the lecture?
Go ahead and go to the lecture.
Okay, very good. I will. So let's stop sharing that and we'll share Canvas and I'll download the, I'm just going to go to home and we're just going to download. Oh, Ella, I have the quiz loaded under here, under video and lectures, or no, excuse me, under test. And it's called Math 65 quiz number 1. You need to, if you could, can you print that out, Ella?
Yeah.
Okay, so you go ahead and print it out now, okay? So we have it ready. We're going to take the quiz at about 6:15. I'm going to give you 35, 40 minutes to do it. Some people can do it in 20, others take 50, so that's why it's that range. So anyway, so you can print it out at your leisure here. In the meantime, I'm going to download the textbook and we're going to do 4-5. Okay. As soon as I can. Just a little slow. Everything's trying to. Okay, here we go. Okay, so so it's on 4-5. So you just click on 4-5 and boom, we're right there. I'm gonna make it a little larger. Okay, like that. Okay, this whole chapter is on the slope-intercept form of an equation of a line. Okay, so here's the guts of it right here, really. If you have an equation, the equation is 1/2 x plus 3, and you're to plot it. Well, what you'll find out is that 1/2, that's the slope. And so m, or the slope, is 1/2. So it's a rise of 1 and a run of 2. So the way you plot this, and the 3, it ends up being the y-intercept. So you plot a point right on 3 where x is equal to 0 and y is equal to 3. And then from there, you look at the slope and it's 1/2. So you go up 1 and over 2 and you plot another point. And you can go up 1 and over 2 and plot another point. So you could have 3 points, draw a straight line. That becomes your linear equation for that equation, that line. Does that make sense? Are you guys familiar with that, what we're doing or not? Is this refresher? Miranda, is this new to you?
No, it's kind of just bringing back.
Good. Okay, good. And Ella, same with you?
Yep, I get it.
Okay, so it's the same idea. So this whole chapter is sort of on this stuff. Okay, so you put things in terms of y is equal to mx plus b, where m is the slope, b is the y-intercept. Okay, that's what that's all about. And here it is. M is equal to rise over run. So just understand that. The rise can either be negative or positive. Okay, it can either go up or it could go down. If it was a negative 4 was m, then you would go down 4 and you'd go over 1. The run is always positive. It always goes to the right. Okay, so if there's a negative value, it's associated with that top number or the rise. Okay, makes sense? You can either, because you could have a positive or negative slope, right? Either one going up or one going down. Okay, so that's what this is all about here. And the slope is 1 over 2. The intercept is 3. And that's when we plotted it up. It was already shown that way. Here's another one. Y is equal to 2x plus 1. So m is the slope. So it's 2 over 1. And the intercept is 1. So here's b is the intercept. So you put a dot right on 1 where y is equal to 1 and x is equal to 0. And then you do this, the slope is 2 over 1. So you go up 2 and over 1, put another point, boom, draw a straight line. That becomes the line for this linear equation, y is equal to 2x plus 1. Okay, does that make sense? This whole chapter is about that, really. That's what it's all about. We just go into little variations of it, but that's what you're doing here, okay? The slope is 2, and the intercept is 1 in this particular case, okay? Okay, we'll move on. Here's another one where y is equal to 2/3 x minus 1. So this particular case, the intercept is at minus 1, where x is equal to 0. And the slope is up 2 and over 3. So you go up 2, that goes up to plus 1, you go over 3, 2 plus 3 on the x-axis. You have a point right there and a point right there and draw a straight line, and you've got it. Okay. That's what you're doing here. Well, wait a minute. This is another one. Y is equal to 1/2 x plus 3. The intercept would be 3. The slope would be up 1 and over 2. Right? Okay. That's what this is all about. Same idea. Y is equal to mx plus b. The idea is you put things in this form. It may not start out in this form, but you use algebra to put it in this form. And there'll be some examples of that too. Okay. Okay, we'll just keep going. Okay, here's one. What you're to do is identify the slope and y-intercept with the equation x plus 2y is equal to 6. Well, you do the algebra and you get y by itself on one side and x on the other side, and that's what we're doing here. First, we're subtracting x from both sides, so we have x on the right-hand side. It becomes minus x. Then we divide everything by 2 because we want to solve for y, not for 2y. So that's why you've got a 2 over here. And then you separate that, and so it becomes y is equal to minus 1/2 x, excuse me, plus 3. I'm losing my voice, sorry. So the whole idea is you change this x plus 2y is equal to 6 into a y is equal to mx plus b format.
What's the difference between 6 minus x and negative x plus 6?
What's the difference between minus x plus and this?
Yeah, like some.
Well, because see on this one, we're dividing both sides by 2, right?
Yeah.
And so when you do that, you get minus x over 2, which is shown right down here. And you also get 2 into 6 is equal to 3. So it's x over 2. I've just split this up. So I got minus x over 2 plus x over, or plus 6 over 2, and that's equal to minus 1/2 x plus 3. Okay. I'm doing this so I want to get it in this format. That's the goal right here. You could leave it like that, but it doesn't, nothing wrong with it, but it doesn't help you graph it, right? That's why we're putting it in this format. That makes sense? Just remember, you can, whatever you do in one side of an equation, you could do in the other, and it's balanced, right? You can add, you subtract, you can multiply, you can divide. You take the square root of both sides, whatever, or you can square both sides. It doesn't change that equation. So that's why you're able to, I'm dividing by 2 because I want y. I don't want y. I don't want 2y. So that means I have to divide on the other side by 2. Okay? Make sense? Miranda?
Yeah.
Okay. So I'm going to keep on going. And the y-intercept is this 3. And you can look, the y-intercept is when x is equal to 0. So you can see if you put this x equal to 0 here, this minus 1/2 times 0 is 0. So y is equal to 3. So that's why you can get that point by putting x equal to 0. You can also put y is equal to 0 and solve for x. And we'll do that a little later too in this section. Okay. So now graph a line using its slope and intercept. That's what we've been doing, really. The steps are, okay, here's the equation. It's already in the right format where m is equal to the slope. In this case, it's 4. The y-intercept b is equal to minus 2, right? And so when you go ahead and graph it, you'll put y is equal to minus 2 and x is equal to 0. So that's that point right there. And then the slope, then you're going to go up 4 and over 1 because it's 4 or 4 divided by 1. So it's a rise of 4 and a run of 1. So the second point would be right up here. And that's probably right down here, right here. They've shown it. Okay. And then you draw a straight line. Okay. You are going to have to get graph paper too. Okay. You just get tablets of it because the homework for Thursday requires that you're going to be doing some drawing. Okay. Okay. And in and then also there will be a test. Not this time. Yeah, actually, and I guess 2 times from now. And you'll have graph paper for that also. Okay. And anyway, so you just got the 2 points, you draw the line, you got your linear equation. So these are the steps. That's what we did. Find the slope intercept form of the equation, or put it in that form, then plot the y-intercept, then use the formula for the slope is rise over run. Find that second point, draw a line between those 2 points. Okay. Okay, here's another one. Y is equal to minus x plus 4. In this one, we've got a negative 1 for the slope. So when we do this, we're going to go down 1. The rise is going to be negative. So it goes lower by 1 and then over 1 to the right. So the rise is negative 1 and the run is always, like I said, is always positive, always goes to the right. Okay. So it looks like this. You started out with the y-intercept was 4. That's why you have the 4 right there. I mean, you have it on 4 and 0, or actually 0 and 4. And then the rise is going to be a negative. You're going to go down 1. So you get down to 3. You go over 1, draw a straight line between those two, and this becomes a negative slope of 1. Okay. Again, just another one. You've got negative 2/3. So that means you're going to go down 2 and over 3, right? And here the intercept is minus 3. So the graph looks like this. Intercept of minus 3. Then you're going to go down 2 and go to the right 3. And that would be your second point. Draw a straight line and boom, you're in business. Okay. All these are like this. I mean, there's more and more, but now here in this one, we want to put this, yeah, we want to put this in terms of y is equal to mx plus b. That's what we're doing here. You would put, you're going to subtract minus 4 from both sides, minus 4x, so you can get x on the right-hand side and y on the left. And that's what you've done here. Then you're going to divide both sides by, you're going to divide by negative 3 is what, yeah, They didn't do this right, did they? This should be a negative 3y. There are some errors in this book. You're going to divide both sides by a negative 3 because that's what you have over here. Because we want y, we don't want negative y. Does that make sense? This is the critical error here on this book. This isn't right. This is right on the right hand side, but this isn't right, and this is right, but they just didn't. They should be a negative 3 down here too. So you could divide the negative 3 into the negative 3, or when you either have two negatives, it makes a positive. That's how you get y down here. Does that make sense to everybody? That's really a critical point, okay? That's a mistake. So then on the right-hand side, you've got negative, maybe I should do this. I don't want to belittle it, but I don't want to overdo it either. But just a minute, let me do this. 4x plus 12. So I'm going to stop sharing. I'm going to go to my whiteboard for a little bit here. Okay. Right here. Okay. I'm going to get a new one. What is it? Let me get this out of here. Sorry. So I'm just going to write down this is what we had. 12, I think that's what it was. So we've already moved the 4 over to the right-hand side. So we want to end up with y. So that means we have to divide both sides by negative 3, right? Not by 3. So that left side looks like, sorry, I'm trying to. So what you're doing is you're dividing this by negative 3. And you're dividing this whole side by negative 3, right? So now on the left side, the negatives, that'll cross that out. So you end up with y, right? And so you end up with y is equal to, and the negative 4x divided by negative 3 ends up being 4 over 3, right? And it's positive. I'll do it like this. And then 12 divided by negative 3 is going to be negative 4. Okay, so it looks like this. Does that make sense to everybody? See, I divided by negative 3 on both sides, not by 3. So the book doesn't show it right. I just want to make sure you don't follow the book in that part. Okay. Yeah, I think that's the second error I found in the book. So it's not a perfect book. I mean, it's made by humans, we all make little errors. Myself included, believe me. Okay. So, but they correct themselves. They get it right down here. So the slope is 4 over 3 and the y-intercept is negative 4. And lo and behold, trying to get you guys out of the way here. Okay. And so it's negative 4 and the slope is 4 over 3. So we go up 4 and over 3. Okay, get that second point. Okay, does that make sense? Here's a couple more. It's the same. Now we've just got one with decimals in it, but it's the same idea. You've got you already have it in the mx plus b format, right? The slope is 0.2 and the intercept is 45. So there's nothing. You can put the scale different on your graph, however you want to do this. But so in other words, instead of having just 1 through 60, you can go by 10s. Actually, that's what they did here, right? 10, 20, 30, 40. So they went up to 45. That was the intercept, and the slope was 0.2. So it means up up 1 and over 5. That's what that means. I don't know why they didn't show that here, but 0.2 is up 1 and over 5. So you would go 40 up 1. Well, see, that's, or you can go up 10 and over 50. Maybe that's what they do. Yeah, you're going up 10 and over 50. That's what they're doing. From 45 up to 55, and then they're going over to 50. So it's 10 over 50, which is the same thing as 0.2.
But we
Okay.
have to watch our scaling because that it's
Yeah,
kind of confusing,
yes, exactly. Got to watch your scaling. Yes,
especially
definitely.
when we're used to doing a different scaling on a different graph.
Yep.
Right.
You have to watch it. Yep, exactly. If you're dealing with large numbers, just make sure that's what you do. Yep, definitely. Okay, now methods to graph. There's another method that you can use. Well, a couple actually. Point plotting, where you can actually substitute values of x into the equation and solve for y. Then you get pairs, and then you just plot those pairs, and you get a straight line. You can use the slope-intercept method. That's what we've been doing. Or you can use the intercept method. That's where you indicate where you make x equals 0 and you solve for y. Well, look at this one up here where y is equal to 0.1x minus 30. If you make x 0, y is going to be equal to minus 30. And so that's 1 point. And that's one data point. And then if you make y equals 0 and you solve for x, you put 30 on the other side, and you divide both sides by 0.1, it's 300. X is equal to 300. I believe that's right. Yeah. That's how you would, anyway. And then the other is if it's a vertical and horizontal line, and we'll get to that. So what they're saying is there's 3 or 4 different methods of solving these equations. Here, if you have an equation x is equal to 2, that's a vertical line, right? That's a vertical line. If you have y is equal to 4, that's a horizontal line. The vertical line, the slope is undefined because the value, it goes larger, it blows up because there's no run. It's essentially 0. You're dividing something by 0. You divide anything by 0, that it's undefined, it blows up. Okay, I call it blows up. It's undefined. On the other one, if y is equal to 4, it's a horizontal line. The slope is 0. Every other thing other than a vertical and horizontal will have a slope of either negative or positive. If you have an equation like this, look at number 3, where it's minus x plus 2y is equal to 6. You can solve this by intercepts. By that, I mean putting x equal to 0, solve for y, putting y equal to 0, solving for x, and getting two data points, and then just drawing the graph. And that's what you do in this one, also number 4.
We put it in the y equals mx plus b form, or
No,
we leave it like that?
no, that's the point. You don't. I'm going to show you.
I understand it. Just, I guess, it's so we're used to just putting it in that
I
form.
know, exactly, but I just want to make sure you
Okay.
you understand the difference. I mean, I
Okay.
understand you understand, but I want to show
I
you.
did.
Okay. I've got to make my money. You know what I mean? I have to do this. Okay. It's part of my job. I'm going to show you. Okay. I'm just teasing you, but I am going to show you. Okay. Go like this. Boom. Okay. So I'm going to get a new sheet of paper here. Pull that away. And we're going to go up here. And I like red. So that top one was minus x plus 2y is equal to 6. Okay, so he said, we'll solve this using the intercepts. So what that means is put x equal to 0 and then solve for y. When x is equal to 0, if x is equal to 0, y in this case is going to be equal to 3. Do you see that? Because if I took this, I put it over here, and I said, okay, it's 0 plus 2y is equal to 6. And then I'm going to have to divide both sides by 2. So y is equal to 3. Okay. So when x is equal to 0, y is equal to 3. That's one point. Then make y equal to 0. So when I have y equals 0, it's minus x plus 2 times 0, right? Which is 0. Get it right here. It's supposed to be a 0. Is equal to 3. In this particular case, I've got minus x is equal to 3, right? 3. But I don't want minus x, I want x. So I have to multiply both sides by minus 1 or divide by minus 1. It doesn't matter. It's the same thing. So I'm going to say minus x or minus 1 times minus x, just to show you, is equal to 3. A minus 1 times a minus 1 is a plus. Oh, on the other side, it's going to be a negative 1 because I have to, if I multiply minus 1 on one side, I have to do the same thing on the other side, right? You have to do that. I have to balance it out. So now on the left-hand side, I've just got x. I've got a minus times a minus. On the right-hand side, I've got minus 3. So I'll be doing this whole thing. I end up with 2 different points. I end up with a 0 and a 3. You put brackets around those things. That's one point. And then the second point, I would put minus 3 and 0. That would be the second point. Graph these 2 points and you have your linear equation. You have your line, right? It would look like this. I'm just going to put it here. If this is 0 and 3, it would be at one point up here would be 1, 2, 3. That would be 1 point. The second one is minus 3 and 0. 1, 1, 2, 3. So that second point's right there. So this thing looks like this. Right? That's what they mean by graphing it by just using the intercepts. We don't use the y is equal to mx plus b. Okay, we're just using this equation up here. Does that make sense? All we're doing is just substituting a 0 in for x and a 0 in for y and solving for the equation. And you get 2 data points, and that's what we did here. Does that make sense to you, Miranda?
Yeah, I guess it's just the difference on when to do which
Well,
one.
they'll tell you what to do. I mean, you can do it either way. Either way is fine, but there's some problems they'll say do it by y-intercept or by intercepts, and the other will say
That's the way to do it, right?
Intercept slope or slope intercept format and solve it that way. They both
Just
work.
different ways of doing it.
Okay.
Okay, thank you.
You're welcome. Okay, so I'm going to stop sharing, but it's important to understand that part. That's okay. Okay, and that's what that's all about. Choosing the way. Okay. Keep going. Okay, this is all sort of the same stuff. See, strategy for choosing the most convenient method to graph, and it becomes a preference too in some of these. But if you have something like this, y is equal to minus 6, well, that's pretty simple. That's just going to be a straight line where y is equal to minus 6. There's only really one way of doing that one. If it's like this, 5x minus 3y is equal to 15, you might consider using intercepts. In other words, put x equal to 0, solving for y, putting y equals 0, solving for x. Or you could change this into y is equal to mx plus b format too. I mean, it's your preference, right? This one's already there for you, so that's easy. So what they're trying to say here is you probably use the intercept method on this one. You leave this the way it is because it already has a slope and intercept, right? That's what they're showing down here. Yeah, the easiest way to graph would be to find the intercepts. Okay, keep on going. Gives an example down here of converting Fahrenheit to centigrade or centigrade to Fahrenheit. And we know that Fahrenheit is equal, degrees Fahrenheit is equal to 9/5 times C plus 32. Well, this is a linear equation. It's a straight line, okay? You could call this, F could be on the y-axis and C could be on the x-axis. and it's like, and it's got a slope of 9/5. It's got an intercept of 32. Okay, you can think of it that way. And that's what they're showing here. They're using the intercept method. They're putting, well, what if C is equal to 0? What's F? If C is equal to 0 up here, this is 0, so F is 32. So that's 1 point. Another one, if C is equal to 20, you'd multiply it out and you get 5 into 20 is 4. 4 times 9 is 36. 36 plus 32 is 68. So when C is 20, F is 68. That's another point. Those 2 points, draw a straight line, and you've got your graph. Okay, that's what they're saying here. Does that make sense? Do you ever think of that relationship as a linear equation? But it really is, right? That's what that's all about. Okay. And they just go on to talk about it here, right? That M is 9/5 on this particular equation. When you have it like this, that on the left-hand side, if it's in the slope-intercept form, the left-hand side variable would be the y. Okay, that would be the vertical one. Okay, and the centigrade would be on the x-axis. Okay. Okay, I'm not going to spend more time on it, but it's right here. Okay. We said when centigrade is 0, Fahrenheit is 32, and that's why you got 32 right here. Another point you could, in fact, the class yesterday, we figured out what this point was, put it down there and drew a straight line. You could go right from here, you could do the 9/5. You could go up 9 and over 5. That's what they did here. Okay, they went up to 41 from 32 to 41, and then went over 5 and drew that line, or do that point and then drew a line. Okay. Okay. This is just a cost equation. That's all they're talking about. What's it cost if you have you're selling pizzas, and their cost model is 4p plus 25. So every pizza costs $4. But so the total cost for the week, it would be a straight line. What does this mean? What's the 25 mean? If this is the cost model and if P is equal to 0, then the cost is 25. What does that mean, do you think? In terms of cost, what's the 25 represent? Any ideas? What do you think, Miranda?
Materials, maybe? Or
Yeah, materials, or it's startup costs.
Because that would stay the same always. That would never change.
That's what they're saying, right? If you didn't sell any product, it's still gonna cost you $25. That's what they're saying. So it's a startup cost or a fixed cost, that kind of thing. And you could graph this, right? You could, where C could be the vertical and P would be the horizontal, and when and you'd see it'd be a straight line with a slope of 4 over 1, right? And that's what they're showing down here. If find the cost for a week when she sells 15, you'd put 15 in for P, so it'd be 15 times 4, 60. So $85 for selling 15 pizzas for a week, that kind of thing. Okay. And they're just redoing it again. $85. Okay. So, and it looks like this on the graph, where this is the vertical line is C and the horizontal is P, right? Do you know what the independent variable and the fixed or the dependent variable would be? You remember that? The independent would be this one down here, the independent variable, and this would be the dependent variable. Because it's dependent upon what's on that x-axis. Anyway, it's another deal. But okay, we'll keep going. Now you could have parallel lines, right, or perpendicular lines. if they're parallel lines, they both have the same slope, right? They would have the same slope, but they wouldn't have the same intercept. In other words, this one has an intercept of 3 on the y-axis. This one has -2, but it has the same slope, right? Okay, we'll keep going. These are also have the same slope. Well, it's undefined slope because it's vertical, right? This would be like x is equal to 2, and this would be x is equal to 5, right? So the slope is really undefined, but they're parallel to each other. Okay. Parallel vertical lines are different. Okay. Here's a couple more that are parallel. They're both negative slopes, but they have different intercepts. One has an intercept of 3, the other is -1. Right? Okay. And then, you can use algebra without graphing it. You can use algebra to determine whether they're parallel or not, right? By being parallel, they would have the same slope. So you have to determine what the slope is. So take this 3x minus 2y is equal to 6, and that's what you're looking at here. And you're putting this in terms of y is equal to mx plus 3, mx plus b format. That's what you're doing here. And then you look at this one. This is already in the mx plus b format. And when you put it together, you see, oh, it's got the same slope, right? It's 3/2, 3/2, but it has a different intercept, so you know they're parallel, okay? Okay. Let me see it here. Here's another one where y is equal to -4. Where is it? Yeah, y is equal to -4 and y is equal to 3. Use the slope y-intercepts to determine or parallel. Well, yeah, in this particular case, if you put it in terms of mx plus b, there is no x, right? In other words, the slope is 0. So that's sort of a redundant one. So anyway, so they're definitely parallel because it's the same slope, right? Okay, slope. Same thing here. Well, they're undefined. They're parallel to each other, but the slope is undefined. Here's one where you'd have it's already in the mx plus b format. This one is not, right? So you're determining whether they're parallel or not. So again, you do the same thing. You have this one already in that form. You want to turn this one into that form, and that's what you're doing here. Just using algebra to do it. And then you're looking at, in this particular case, this is exactly the same. It's the same line, right? It's just in a different format. It's a line that overlaps the other line, right? Because it's got the same slope, plus it's got the same intercept. So it's the same. That's what that tells you. Okay. Now, perpendicular lines. This is different. A perpendicular line is where one slope is the negative reciprocal of the other slope. So what does that mean? So if I have a slope of 1/4, the negative reciprocal of that would be 4/1, but with a negative sign in front of it. So it would be -4. This is perpendicular to this. That's what that means, okay? Because it's a negative reciprocal. So if you're asked to figure out whether the lines are perpendicular or not, you determine whether the slopes are a negative reciprocal of each other. That's what you're doing, okay? I'll give you an example. Well, this is an example, but this is perpendicular to this. This would be a right angle here, okay? It just so happens that this one is the 1/4x minus 1. That's this line right there. And this other one is the -4. You can see there, this is a really not much of a slope. This is a 4-to-1 slope. Anyway, and so they're perpendicular to one another. And you can see also, you can see if you multiply one slope by the other slope, if it becomes -1, then they're perpendicular to each other. That's another way of looking at it. It's the negative reciprocal times the initial slope ends up being -1 when you multiply them together. So it's always true of a perpendicular situation. Okay. So you have to know that. Use slopes to determine if this is perpendicular to this. So again, you just have to do the math, and that's what they're doing here. This one, the slope is already -5. You know that, right? The second one is here, and you determine the slope is 1/5. So are these perpendicular to one another? What do you think? Anybody? Ella, what do you think? Is this y is equal to -5x minus 4? Is that perpendicular to this line, y is equal to 1/5 x minus 1?
Yes.
Okay, yes, it is, right? Because it's a negative reciprocal. -5 is the negative reciprocal of 1/5, right? Okay. And here's the proof is that you multiply that slope by that slope, you'll get a -1. And that would tell you it's true. Okay. Okay, so understand that part. There isn't too much more in this section, I don't think. Okay, and again, it's just determining whether they're perpendicular or not. Same idea. Determining one slope, determining the other slope. What about this one? If it's -7/2 and M2 is -2/7, do you think they're perpendicular? Anybody? No, right? Tessa's nodding her head. It's no, because if you multiply these two together, you're going to get 1. You don't get -1, right? That's the test right there. Okay. So just know that. Okay. And there's the exercise, and this is what you'll be doing. Take a 10-minute break, and then we'll come back and we'll talk a little bit about the quiz, and you guys can start doing it, okay? But I'll give you a little break. Okay, 10 minutes. We'll see you in a bit. So wait, all righty. 10 minutes. Okay, I'm gonna share. Oh. Hmm. Log in account. Courses, 65. Oh, shoot.